When you study mathematics, you have to confront the unknown.
Math is part of the fabric of the world. Every object that you use, everything you do, every machine, your schedule, the buildings that you're in. Just think carefully about how math is involved in any of those things.
When I was little, I used to lay in bed and just count. At some point, I realized that you could just keep counting forever.
Mathematics is an intense love of clarity of thought with explanation and verification.
Mathematics has always been a subject that moves in unexpected directions.
Erdős was famous for saying there's a book of mathematics out there somewhere, and that book has all the correct proofs, the proofs that are beautiful and capture the idea and really get to the essence of things. And every now and then, as a mathematician, you happen upon a proof from the book.
What is mathematics?
Yes, that's like trying to describe what air is.
Lots of people have tried to define what mathematics is.
I don't know is actually an honest answer. Philosophically, you might say mathematics is the study of things that have to be true in every conceivable world.
Mathematics is the study of things that are true only because of logic.
It's the highest expression of the human spirit and creativity.
Math is the science of patterns.
Patterns and structures in the world.
There's some unknown out there. There's some pattern you haven't seen yet. And mathematics is how you find that pattern and describe it.
And once those structures are conceptualized, we study them and build a huge corpus of theorems, of results.
For me, math is primarily an art form.
The ideal is to discover something beautiful, something elegant.
Mendelssohn once said, you cannot put music into words because music is too specific for that. And the same might be true for mathematics as well. So at some point, I am lost for words.
When I was a kid, I decided I wanted to become a philosopher of electronics.
My father would take us to his bowling league, and when I was 3 or 4, I started keeping score.
I have been doing mathematics, at least in the sense of playing with numbers, as long as I can remember.
I started out really disliking mathematics.
In 7th grade, a math teacher invited me to go to a math competition.
I realized that if I had to pick a subject that I just didn't want to do without for the rest of my life, the only one that I couldn't imagine deleting would have been mathematics.
Math is a very creative discipline. I can do math for a long time without getting tired of it.
I just found some things in math so beautiful.
The puzzly side or the creative side is what really made me fall in love with mathematics.
Essentially, my first day at MIT, I realized that what I thought of as philosophy of electronics, everybody else called mathematics.
I didn't really understand what mathematics was about until after I came here.
There are just a lot more mathematicians, people who declare themselves mathematicians in the world now than there ever were before.
If you had gone to somebody 100 years ago and told them that within a century the United States was going to be a world leader in mathematics, they would have thought you were crazy. What changed was in the 1930s. There was this huge influx of really top mathematicians out of Europe and into the US. People like Zariski, Brouwer, Alfors. They were the core of what we now think of as the Harvard Math Department.
When you think of all of the great faculty who, through the history of the department, have made fundamental discoveries in math, when I first arrived, it was very intimidating.
I was used to thinking of myself as a weirdo outsider, and to come to Harvard meant like I was going to have to give up that identity. But when I got here and saw what really goes on, I was just astonished.
We're a small department. We're less than 20 full faculty.
Because it's smaller, there's a sense of collegiality and there's a sense of group spirit.
There's a very particular choice of subject matter that's celebrated in the Harvard Math Department.
The mathematics that many of us here in this department do is considered pure mathematics.
I began as a topologist.
I think of myself as a geometer, so I primarily study shapes.
That transformed into a love of dynamical systems,
which is an area of mathematics which studies anything that evolves with time.
My field could be called complex analysis.
I became more interested in algebraic geometry.
Differential geometry, the study of smooth spaces.
I do what is called mechanism design.
Homotopy theory.
Symplectic geometry.
I study probability theory and combinatorics.
Combinatorics is the study of finite or discrete structures.
Now I've been working largely in what's called number theory.
Number theory.
Number theory.
It's a subject that goes back to the ancient Greeks, and it's about finding solutions to equations in whole numbers and integers.
All of these subjects, they meld into a single, coherent, very beautiful idea of what the core of modern mathematics is.
When I was in high school, what research I did at the time, I mostly did with my dad's 10 or 13 digit calculator.
It used to be, if you wanted to learn modern algebraic geometry, you had to go to talk to Grothendieck in Paris.
Over time, mathematics has evolved from fairly concrete questions about numbers, about geometric figures, to higher and higher levels of abstraction.
The entire community is doing things that weren't conceivable before.
You need to learn to value your ignorance.
One misconception I'd like to clear up is the fact that we don't know everything about math.
What we're really doing as mathematicians is learning how to abide in a place of ignorance and how to move ourselves around and sometimes into knowing.
There's way too much mathematics, even way too much number theory, for me to understand all of it.
There's hundreds and thousands of open problems and conjectures and questions we don't know the answer to, and more questions and conjectures are being posed.
I think there's a quote of Grothendieck. I'm probably going to butcher the quote, but it's something like, the measure of a mathematician is the quality with which he listens to the nature of things. It's not just a question of like hitting it with hammer and tongs. The problem will talk back to you, but you have to listen very carefully to what it's saying.
It's one of the few disciplines that students will encounter where it's not a matter of the glibness of an argument or persuasion, but where you can be right and you can be wrong.
There are a few so-called axioms, and based on those, we have a logical system of deduction that leads to everything else.
It's CeeLo P subgroups. So Z, mod, P. When we say we know something or we have figured it out, we don't simply mean that we've observed a pattern, but we mean that we have given an airtight logical proof that that pattern goes on forever.
But finding that formal proof is challenging.
This is often a matter of trial and error.
If I'm trying to prove something, I need to convince myself that what I'm trying to prove is actually true. I have to believe in it.
At some point, you have to basically stare at a piece of paper or stare at nothing and just think.
Sitting there just and getting nowhere is a very important part of the process.
It certainly develops your patience, your perseverance, especially in the face of failure.
But that's not the only thing you can do in math. You can try to find interesting examples, you can make conjectures, you can make webs of the conjectures motivated by the examples.
Conjectures, of course, are motivators. They're inspirers.
I'm terrible at making conjectures. There are conjectures I probably should have made, but didn't make, and my experience is when I tried to make a conjecture, it was wrong.
It's very interesting when you're wrong, and being wrong is fruitful.
That discovery maybe opens a whole new door, what is the expression? A whole hallway of doors, in fact, of different things that we might want to explore.
Questions that you would never have asked had you been right. Of course, it's totally important to be right eventually.
There's always this question, is math an art or a science? I think it kind of has elements of both.
One often hears that one is seeking beauty in mathematics. That may be true, but I think more one is seeking understanding. The bonus of your understanding is always that it's beautiful.
It's a beauty that's not a surface beauty. You have to have some kind of knowledge to penetrate that beauty. But once you do, I think it's beautiful and speaks, to me at least, in the same way music speaks to me.
Everybody in mathematics has a sense of the beauty of the subject, but everybody's sense of the beauty of the subject is unique to them.
Mathematics is beautiful. In some ways, like poetry. It's a way to express something so essential.
For me, the beauty is in the understanding.
For me, the infinitude of primes stands out. The reasoning involved and the argumentation, it just has a particular aesthetic to me that resonates.
I see beauty in mathematics in some of the ideas that lead to proofs. The proof captures the central idea of the mathematics behind it.
It's always been about the geometry, the shapes of the objects that we deal with.
As we go on in mathematics to more advanced, the beauty only grows. And one sees not only beauty in small scale, in individual arguments, and in the craft of mathematics, but also beauty at a large scale, in the way that entire theories develop and theories relate to each other.
Mathematical beauty for me is the surprise when you realize that two mathematical objects that you didn't think should have anything to do with each other actually turn out to be deeply interconnected.
All of a sudden, it opens up to an area about which you know nothing.
Then you realize how there's some other underlying principle or a new mathematical theory that will explain why this is actually equivalent to that. And that, to me, is the most beautiful thing we can do in mathematics.
In physics, you are constrained by the world. You can make up a beautiful system, but if it doesn't correspond to the actual world, it's not particularly valuable. In mathematics, you can make up any system you want.
As pure mathematicians, when we do our research, it's impossible for us to know whether it's going to have a real-world impact or not, and if so, what it'll be.
It's essential to do it because there can be no other research without pure research.
A lot of mathematical applications are not anticipated. Coding theory is based on number theory that was done a couple centuries ago, and it was done by people who were just doing it out of curiosity.
Even such a basic thing as Boolean algebra. Boole was an English mathematician in the 19th century. Bringing algebra to logic was only one of the small things he did, but without that, we wouldn't have any of the modern computational tools that we have.
It used to be quite solitary. It has this reputation.
Sitting by ourselves, just taking notes by ourselves all day, which, okay, admittedly I do. I do spend a lot of time just sitting and thinking by myself.
But that's changing a lot.
The next thing they do with those thoughts is go and tell somebody.
Being in the Harvard Math Department is such an amazing experience because of all the people who are here.
Harvard embraces all of international mathematics.
It's just amazing how you can sit here and the mathematical world comes here. There are always people coming through.
If you go into our lounge, you see people collaborating. You see people sharing their love for mathematics and the problems they're working on.
If you have a math question about something you don't really understand well, somebody else here will know the answer if it's known.
Or say something unexpected that would help lead you to an answer.
So my colleague, Barry Mazer, who I admire a great deal, has this beautiful line that mathematics is a long conversation.
Mathematics doesn't go out of date. You can imagine having a conversation with Euclid.
My daughter, who's in high school, said, "Dad, how come you're so good at math?" And I said, I thought about math nonstop for 22 years, right, until she was born.
I'm kind of immersed in math all the time.
Math is always there, no matter what.
I might do math while I'm walking outside. I might do math just before going to sleep.
But I would say one of the few times I didn't think about math was when I went fishing.
It is nice to take a break sometimes and to Allow that math to just sit there.
I really was interested in possibly becoming a filmmaker.
I love to go hiking.
And then I discovered that it's much easier to be a mathematician than a filmmaker.
I've been probably spending too much time with word puzzles.
Sleight of hand magic.
Logic puzzles.
There was a period of years where all the mathematicians were juggling.
Going to the rock climbing gym, it requires total physical and mental concentration. It takes you out of everything else into this other world.
I write poems. For my wife's birthday, I give her 100 of them.
The main thing I do outside of doing math is playing soccer. That kind of eclipsed everything else. When I see these ads that say birth, soccer, death, I know exactly what they're getting at.
Getting the body in motion is a way to get the mind in motion. Many times I've sat all morning and worked on a problem, and then I go out for a walk or a bicycle ride, and when I come back, there's progress.
A lot of mathematicians are also musicians. For example, I play the piano.
I think the link between mathematics and music runs deep. They both speak in an abstract way.
I'm taking piano lessons. I have a lesson on Sunday that I am not prepared for.
Well, I'm a fallen trombonist.
I used to play in a heavy metal band when I was in high school and in college. Pretty heavy.
There's not much opportunity when you're writing a paper to put your emotions into the paper. Music is all about emotion, so I personally find it very satisfying.
The largest musical instrument that I play regularly is probably the bells of Lowell. The biggest one is about 50 kilos, bigger than Big Ben. It's a somewhat exotic musical instrument, but it's still music.
Teaching is one of my favorite parts of the job of being a math professor. It's immensely rewarding just to see the evolution of mathematical thinking in their minds. I feel like I can really make a difference in their lives.
You know, it's not just about training future mathematicians.
The way that the students are taught to think, as they're learning to write proofs, as they're learning to write coherently, these tools are useful in any domain.
Studying mathematics really trains your brain to think very systematically.
How to think carefully about things and rigorously about things.
See the world through reason. I think it's very important and perhaps still a little rare.
One of the major changes, of course, is the advent of modern computing. The ability to do simulations and visualizations in ways that we could not have done 50 years ago. And also the advent of artificial intelligence and machine learning to automate the process of making conjectures or possibly even automate the process of proofwriting.
I think of myself as having been in dialogue with computers in some sense through most of my mathematical career, and now the computers are literally talking back to me.
AI operates as a black box. It doesn't give you sightlines into the thinking and the reasoning, and too many people just accept the output. You know, I think if we do a good job in the mathematics classroom, we can help students remain healthfully skeptical, help them really engage with the thinking and own the conclusions. You know, what better contribution can we make?
The fact that people continue to find new statements to make about the whole numbers is typical of the eternal nature of the questions that are being investigated in mathematics.
There's a lot of development happening, and in many, many different areas of mathematics.
The idea that there can be a mode of language, of thought, of explanation that is meant to be utterly universal and beautiful at the same time, all that is exciting to me.
There's still so much that people don't know. There are these even pretty basic questions that you could explain to someone in middle school that are remarkable unknown questions in mathematics.
There are endless possibilities.
What makes math so exciting to do is you never know exactly where you will end up.
I'm not quite sure yet what exactly those endless possibilities are. And I can't wait to find out.